Good morning, Year 7. I hope you're all still keeping safe and looking after yourself. And welcome to what will be the first session in the second week of remote learning. I hope you really enjoyed the first two sessions from last week. And today we are going to be looking at types of triangles. Now, today's lesson is going to be slightly shorter than usual because the second session in this week's maths content is going to be slightly longer, just to compensate for that, because today's quite a short topic. Now, if you remember from last week, we were looking at angles and we were looking at angles on a straight line. And this week, we're going to be looking at something that's related, which is triangles. And then in tomorrow's session, in the next session, we'll be looking at angles in a triangle, which you'll be able to use the knowledge that you learned before. Now, what I've just got to start off with is I've got a picture that's quite appropriate. Now, we're looking at triangles today. Now, you can pause the video if you want. It's completely up to you. And I just want you to count how many triangles can you see in that diagram. Now, I'm not going to go through the answer, but you can just have a look at that diagram and see how many triangles can you see in that diagram. Okay, make sure you think outside the box because there's quite a lot of triangles in there, but it will take you a while to see them all. So what are we actually looking at today? Well, we're looking at how can we identify different types of triangles, what are they called, and what are their properties. So before we actually make a start, most of you will know what a triangle already is, but I'm just going to do a little bit of a recap. So I've got a triangle there on the right hand side. So how can we actually define a triangle? Now, to start off with, we can categorize it as a two-dimensional shape. So 2D stands for two-dimensional. And that just means that the shape is flat. So that means it's like a surface. So if you look at your table, now you know that your table is two-dimensional, the surface, but the actual table is what we call three-dimensional. Now, a triangle also has three sides, three lengths. Now, if you look at this triangle, we've got one there, and another one there. If the shape isn't a three-sided shape, then it can't be a triangle. So a triangle has to have three lengths, it has to have three sides, and it also has three angles. Now, we should all know what an angle is from last week. If we look at this triangle, if you look at where two sides or two lengths meet, we've got one angle here, and one angle there. So we've got three sides and we've got three angles. Now that's really, really important for you to remember. Now this fourth fact here I've just added in. Now the angles in a triangle add up to 180 degrees. Now you won't need that for today. Most of you will already know that, but we'll need that for tomorrow's session, but it's just a nice fact to kind of breeze over. And today we're looking at what are the four types of triangles. Now, because we're in high school, you'll have seen it in primary school anyway, but because we're in high school, it's not enough just to identify something as a triangle. We have to be more specific. So today we're looking at how can we be more specific and how do we know what kind of triangle it is. So the first kind of triangle we're looking at today is a scalene triangle. Now, be careful with the spelling. Now, a scalene triangle, so I've got two scalene triangles here on the PowerPoint. It means no of the lengths are equal in size. So if you look at all of the sides, none of them are equal in length. So for example, if you take this one here, we could have a length of, say, 5 centimeters there. We could have another length of 6 centimeters and another length of 10 centimeters. Now, that's what makes that scalene. All of the lengths are different, but not only that, all of the interior angles are also different. So that means the size of the angles, interior means inside, all of these angles on the inside of the triangle also have to be different. So for example, they could not all be the same size, or two of them couldn't be the same. They all have to be different. So that's your first kind of triangle, and that's a scalene triangle. Okay, so the next thing we're going to look at, next triangle, is an equilateral triangle. Now, Equilateral triangle is another triangle, but this time all three sides have to be the same length, every single side. Now, if you look at this diagram, we need to know, by looking at that diagram, in what way is that diagram telling us that all three of the sides are the same? Well, we've got what we call, and I'm going to write this out, geometric notation on that triangle. Now that seems like a really complicated word and you don't need to remember what it means, but geometric just means a diagram and notation just means something on that diagram. Now if you look, I hope you can all see those red lines. Now those three red lines mean that all three of those lengths are the same size. So if we were to say, and I'm making this up because we don't know how long they are, if I say that that red line has a length of 9 centimeters, then that diagram is telling us that all three lengths have to be 9 centimeters. So we can go ahead and we can write that that length is 9 and that length is 9. So that makes that equilateral. Now, is that the only property of an equilateral triangle? No, it's not. Not only are the lengths the same, but the angles are also the same. Now, some people in my class will already know the size of each angle in an equilateral triangle. I'm not going to go over this. If you do, then that's brilliant. We'll look at that in tomorrow's session. But all of the angles in that triangle also have to be the same length. And we can see that by the notation. Do you see how each angle has one line forming the angle there? That means that they're all the same size. Okay, so we've got two triangles so far. We've got scalene and we've got equilateral. So we've got two more to go. Feel free to pause if you want to take time to do the notes. Our third triangle, and probably the hardest one to spell, is isosceles. Now, isosceles triangles have two equal lengths and two equal angles. We call the angles that are the same base angles, but we'll go over that in the next session. Now, I want you to just look at this diagram. I'll circle so you know which one I'm talking about. I just want us to look at this diagram here. Again, if we had that in an exam question and we were asked what type of triangle is shown in the diagram, how would we know it was isosceles? Well, again, if you look at this notation here, that means that those sides are the same length. So let's say this is 7. Okay. If that length is 7, then the other length, which has a little line on it there, also has to be 7 centimeters. Now, some people would then say, well, if that's 7 and the other one's 7, is the bottom one not 7 as well? Well, that's where people make a mistake. There's no line on the bottom there, so that suggests that that length there has to be different. Now, it can be bigger and it can be smaller, but if you look at that with your eye, then you'll probably be able to see that that's smaller. So we could make a little upper length for that as well. So we'll say that that one is 4. And that makes that an isosceles triangle. Now, don't forget, not only are two lengths equal, but two angles are also equal. So, for example, if that angle there was 40 degrees, that angle there would also have to be 40 degrees. Not touching on the angles too much because we'll be doing them in the next session. But just remember, isosceles has two equal lengths, one is different, and two equal angles, and the other one is also different. Moving on, now I'm going to just talk about the right angled triangle on this slide as well. A right angled triangle, which is spelt, make sure you put a hyphen, so right angled triangle, is the easiest one to remember. Because a right angled triangle, all it means by definition is it has a 90-degree angle. Now, we should remember from the last session that a right angle, okay, right angle has to be 90 degrees, okay? And if you look at this diagram here, we've got a right angle. So that makes that a right angled triangle. Okay, this one in particular is called a right angled isosceles triangle. I'll leave people to work out why that might be called a right angled isosceles triangle, but don't worry about that one for now. We just need to know that it's a right angle triangle means that it has a degree inside. One of the degrees is 90 degrees. Now, what I'm going to do is I'm just going to quickly go back through, and I just want to specify that if you look at the property for the lengths, the property for that triangle is identical in the angles. What I mean is, scaling, all of the lengths are different, all of the angles are different. Equilateral, all of the lengths are the same, all of the angles are the same. And isosceles, 2 of the lengths are the same, and 2 of the angles are the same. So you can see that the angle and the length property for each triangle are both the same. However, in a right angle triangle, you don't need to worry about the lengths. A right angle triangle, you just need to worry about the angle as 90 degrees. Now, your first task to do is you've got 4 triangles on the left-hand side. You've got the names of 4 triangles and the properties, and you need to match the diagram with the name and with the property. Okay, if you need to go back and make notes before you do this, feel free. So I want you to pause the video now, and I want you to match each column one by one. So the diagram to the word to the property. So you should have had a go at that activity now. What I'll do is I'll use different colours to match each of them. So I'll start off with red. So we'll start off with this triangle in the top. So we'll colour that in red. Now, I look at this triangle and I think, right, so there's a line on each side. So that means they're all the same. So that must be my equilateral triangle. Okay, you've probably already figured out equilateral. Equal means the same. For example, 3 + 2 = 5. Equal means that they both mean the same thing. And that means that you've got 3 equal sides and 3 equal lengths. Let's move on to the next one. Like I said, probably the easiest one. You should see this right angle and automatically your brain should think that's a right angle triangle and it means it has 1 right angle. Well done if you've got these right so far. If not, hopefully you've realised where you've gone wrong. Okay, the next one we're going to look at is this one. We'll use blue. So we've got 2 equal lengths, but the third one isn't the same. So that means only 2 of the lengths are the same and 2 of the angles are the same. So which one was that? Was it isosceles or was it scalene? Well, it was isosceles. Remember, the really hard one to spell. That means 2 lengths are the same. And again, so this means it must be this one, 2 equal sides and 2 equal angles. Right, now we're going to look at the last one. Now, I've picked an awkward diagram on purpose because I just want to actually discuss what the geometric notation means. Don't forget, geometric notation just means how it's notated. Now, if you look, on one of the lengths there's 1 line, on another one of the lengths there's 2 lines, and on another one of the lengths there's 3 lines. Now that looks complicated, but all it actually means is that all of those 3 lengths are different, which is why they have a different number of lines on each one. So if they're all different, then that diagram surely must be scalene. So we'll call that scalene, and by process of elimination, it must be that it has no equal sides or no equal angles. Now, feel free to pause that if you want to mark your answers at the end. I'm going to clear that for now. And what we're just going to move on to is you're going to have to pause your screen. I mean, we can go along with the timer. Which one of those is an equilateral triangle? Is it red, blue, green, or yellow? So the answer for that one is actually yellow. So yellow is the equilateral triangle. Okay, next one. Which of those is an isosceles triangle? Is it red, blue, green, or yellow? So just think of the answer in your head. Okay, you've got till the timer ends. So the answer for that one is blue. Don't forget, isosceles means 2 lengths are the same and 1 length is different. Okay, next one. Which of these is a right angle triangle? Is it red, brown, green, or yellow? Well done if you got that one right. So the answer for that is brown. Remember, right angled means it has a right angle. One of the interior angles is 90 degrees. Next one, a scalene triangle has one pair of equal sides, all sides equal, all sides different lengths, or two angles of the same size. Okay, the answer for this one is dark green. All sides are different lengths. If you remember as well, if all sides are different lengths, then all angles must be different as well. Next one, a triangle has four sides, interior angles equal to 360 degrees, interior angles equal to 180 degrees, or exterior angles equal to 180. Right, I covered this fact briefly. Interior angles in a triangle add up to 180 degrees, but don't worry too much if you forgot. Now, if you have three touching triangles, do they make a pentagon, a square, a hexagon, or an octagon? This is quite a difficult question. Maybe try drawing it out and pausing the video. So, if you look at the diagram, if you actually draw three touching triangles, it makes a pentagon. A pentagon is a five-sided shape. Ooh, next one. Four touching triangles make a pentagon, a square, a hexagon, or an octagon. So feel free to pause the video and you can have a go at drawing it. Let's have a look. So we actually get a hexagon, which you might have been able to work that out because if three triangles make a five-sided shape, if you add a triangle on, it actually increases the length of the polygon by one. So it's a hexagon. Right, what I'm going to do for this week is I'm going to host a little bit of a competition. So if you can, I'm challenging you to make a poster on the different types of triangles. Now, feel free to be as creative as you want, and you can send a picture to my email at the end, as you normally do anyway, with the rest of your work. And the top three students who's for the best three posters will get a reward when you return to school. And make sure you nag me for it, obviously. But I will, in one of my online videos, I'll announce the winners of the competition. It might be 2 weeks after this video, but as soon as I've looked at the posters, I'll announce the winner. So I'm looking for creativity. Make sure you're using a ruler when you do your drawings, and I'm looking for definitions and some nice drawings on your poster. So make sure I can tell which triangle is which. Now, what I've got here is these are some optional questions, particularly for my class and for Miss Loon's class, but I would recommend that everybody has a go. And I would like you to send these questions to me personally via email, and I will give you feedback on these questions, and I will mark your answers as I go along. So you can pause the video, you can have a go at these questions, and then you'll be able to email these questions to myself and I will give you some feedback on them, just so the video's not too long for those who aren't taking part in these questions. Now, just after you've had a go at those questions, I would like to thank you for watching today's session. So it was a little bit of a short one. Like I said, the next one will be a little bit longer. Now, I know last week for the lessons, I asked you to send all of your work to Miss Clark, apart from my set to send it to myself. But now what we're going to do is if everybody sends me your work for the remainder of this period where we're doing the remote learning, and I will forward your work onto your subject teacher, whoever you've got this academic year. So can you just obviously make sure so that I could forward your work to the right member of staff, make sure you've got your name and your class teacher's name in the subject title of the email. And we have got a Friday drop-in session happening, 9 till 9:30. That's going to be on Zoom. And for those who want to do some further work, a topic which I would recommend is, can you look at types of quadrilaterals? Now, there's lots of different types of quadrilaterals for you to look at. Some you'll know, some you won't know. So just have a look at those and have a look at the properties involving those different quadrilaterals. I hope you all keeping safe, guys. I hope you all working hard, and I'll see you in the next session for this week. Bye.